are recording at this time. So today what we're going to do is sketch graphs of equations, and most of you have already put that in your table of contents. You've already turned to that page. But before we actually start with graphing, some of the basic ones that you should have an idea of, let's go and talk about where you would ever graph an equation in real life. Can anybody give me an example of when you would actually need to know something like this? Okay, yeah, and in fact, like the government does that. Like if you own a business and your sales are here and then they increase and all of a sudden they decrease like that, they're gonna call you up and say, are you stealing money? Or there's something up. Like that's an extreme happening. Anybody else? Okay. So a couple that I came up with. The sale of iPhones. If you actually look at iPhones over time, it's increased. The iPhone is actually one of the most popular phones, and it keeps increasing and increasing and increasing. One of the ones most of you would probably need to look at, car prices. You buy a car, it starts depreciating. So when do you want to sell your car so that you have X amount of money to put towards your next car? That's a useful thing in real life, right? So let's graph some of the basic functions that you should know. Raise your hand and tell me how to graph any one of those. Tell me what it looks like. Whitney. Good. So the first one's just a line. I'll just draw it like that. How's that work? Now, technically, where is it going through, even though my graph doesn't show it? I messed up. Should go through the origin. It has a slope of 1. So if it's just x or mx plus b, it's a line. Okay, somebody else raise your hand. Tell me what the second graph looks like. Perfect. Good vocab word too. Parabola. U-shape. U-shape. All right, Ryan, you actually looked at this next one. You said, oh no, we're not doing absolute values again. But yes, we are. And I don't want you to be afraid of them. But do you remember what they look like? What letter of the alphabet, maybe? Yeah.
What did you say the slope was for
this one?
Yeah.
1. 1x. Anybody know what the square root of x looks like? Slightly, maybe. Whitney? If you went like that, is a cube root graph. Yes. Yes. It's just that. Very good. So, hopefully you remember those graphs. Maybe it's been a while, but they are all graphs you've seen in Algebra 2, correct? None of them are new in any way. So let's look at our first one we're going to graph. And actually what I'm going to do is say, write down that and try graphing it on your own. You can just make yourself a small graph right in your notes. Now, it may have been a while since you've done this, whether it was last year or for some reason you did it in another class earlier this year, I'm not sure. But that's the latest it should have been, because even in geometry class, you guys graph lines, right? You talk about parallel lines, perpendicular lines, so those are things that you do. So you start at 2, and you go down 3 over 1. Down 3 over 1. And we draw our line. Let's try that again. And there we go, we draw our line. Took me a minute to draw a straight line, okay? Raise your hand if you got that one. Okay, so the first graph, pretty simple. Next graph. 1 minus x squared. Now this one we're going to do together, and we're going to talk about it a little bit. Because I know if you had geometry last year, you did not do this in geometry class. But if you had me last year, you did do this in Algebra 2. Now if you had me 2 years ago, we did it in Algebra 2, but it's been 2 years, so probably don't remember it. But x squared, Brandon, you told me looks like a parabola. So I know this is going to be a U shape. Now I have a couple options to graph this. What is one option you could do to graph this? And you can actually do this with any equation I ever give you. No, because I won't let you use a calculator on this first quiz. Now technically, yes, calculator would work 100% of the time, but I want you to be able to do it without. That works 100% of the time, an XY chart, right? But instead of doing an XY chart, let's see if we can do it without. So I have a negative x squared, right? Now which thing do I like first? Do I like the 1 or the x squared first? I like the x squared first. So I'm going to rewrite this like this. Anybody know what the vertex is? Remember, a vertex is going to be something comma something. Justin? Okay. Whitney? Not quite. Switch it around. 0, 1. Okay. It is 0, 1. Now, here's why. First off, notice there's no regular x in the middle, right? So what I like to think is switch the sign of what's inside, keep the sign of what's outside. So notice there's nothing inside parentheses here, but there is something outside there. Make sense? Okay. Let me just give you, we'll continue on this example here in just a second. Let me give you another one instead. X plus 2 squared plus 1. What would be the vertex here? Sparta. Yes. Does that make sense? Does that help? Okay. So I'm going to clear that because that's not what we're graphing. We are graphing this. So I started 0, 1. I'm actually going to plot that 0, 1. Now, am I a happy parabola or a sad parabola? Sad. Okay. And if you had me last year, we actually made a table to help us, an XY table. And we put in our table 1 and 2, only 1 and 2. That's all we put in. What's 1 squared? What's 2 squared? 4. And if there's a number in front, which in this case is negative 1, we multiplied our y values by that. So this will become negative 1, this will become negative 4. Now, if you had me the year before, I'm not sure if I covered this as much. So see if you can follow along as we do this. After you have your vertex, then from there, I'm going to go over 1 and down 1. So over 1 and down 1. And I'm actually going to do that on both sides. So when I say over, I mean both to the left and to the right. And for the 2, I'm going to go over 2 and down 4. And over 2 and down 4. Then I just make a U. And that's it. Now, I would try to practice it that way, but if let's say you're doing your essential work, or you're taking my quiz and you need to graph this, and you forgot how to do that, go with Mallory's way. Make a table of values. That works. And I'm fine with that as long as you show me the table of values. Sound good? Okay. So now we're going to find the x and y intercepts. And x and y intercepts actually can be found the exact same way no matter what equation I give you. tell me how I find an x-intercept? Let's take a guess. How do I find an x-intercept? That is correct. Good job, Trevor. Put 0 in for 1. Oh no. If I do that here, I get 0 equals negative x squared minus 5x. Now this probably looks scary to you. And this is something you should still know how to do because I kind of beat it into you no matter what year you had me. But this is an F word you're allowed to use in school. Not FOIL. Factor. Factor. This is the one word that you really need to know. Factor. So, what's the first step of factoring? GCF. Guys, remember me repeating that? GCF. What is the GCF here? Negative 1, x. Notice there's an x in both. So I'm going to plot negative x. Now I'll have left x plus 5. Since I pulled out the negative, that has to become a positive. Now what do I do with each of the pieces? Please wake up and talk. Thank you, Whitney. So right here, this would be x equals 0. And this would be x equals negative 5. I set them each equal to 0. So negative x equals 0. Divide by negative 1. I get x equals 0. If I set x plus 5 equal to 0, I subtract 5. I get x equals negative 5. Now, I honestly feel you're at this stage where if you feel comfortable going from here straight down to here, I understand how you got that. Make sense? But if you don't, you need to show your work. But if you looked at this and you said, okay, negative 5 plus 5, that makes 0, you can just write that and I'm good. Sound good?
So you basically split it up between negative x, split up between negative x and something like that.
Yes. So I split it up between the two things that are being multiplied.
So you always do that.
Yep.
No matter what.
That's why I have to factor it.
Always split the y.
Okay. How do you find a y-intercept? Oh, go ahead, Brandon.
So for that, you're just using like negative x equals 0 as one equation and then x plus 5 is another equation.
That is correct. Now, how do I find the y-intercept? Mallory. Good. Go ahead and do that for me. How many of you got 0? Okay, good. Which one do you like better? The x-intercept or the y-intercept? Good. That should always be your favorite. It should always be your favorite. It is honestly always the easiest one to do in this class. As I said, in this class. Because in calculus, he probably goes into more depth. It's probably not as simple because the equations are harder. But in here, that should always be your favorite. Okay. Listen, I know it's a lot of writing. You only have to write it once, and I'm not going to speak for the next few minutes. In fact, we're going to pause our lovely recording and let you have time to write this down. Okay. So now that we have that copy down, we have our first problem up here. We're going to determine the symmetry of this. Now, obviously it's not graph. So instead we're going to use the algebraic test. Okay? And I'm going to change this slightly, hopefully. There we go. So we have some room. So, first thing I want to do is I want to check if it is symmetric about the x-axis. negative y. So let's plug that in. Negative y squared equals 6 minus x. And remember, once again, this is for checking the x-axis. What is negative y squared? What happens? It what? It becomes a y. A y squared, right? Equals 6 minus x. Now, the question you have to ask yourself, is this the exact same as this? Yes. So it is symmetric about the x-axis.
Question.
Go ahead.
Why wouldn't it be y equals 6 minus x because it's already...
If I square it though, it has the squared on it. So
Well,
it's squaring both the negative and the y.
well, you're doing negative y times negative y, so I get that, but I mean, the square root of y.
Well, what's y times y? It'd be y squared. That make sense?
Yeah.
Alright, now I actually want to run through the other two just so you can see that. So let's check the y-axis next. Notice whichever one I'm checking, I put in the other letter. So if I'm checking y-axis, I'm actually going to put in negative x. So I have y squared equals 6 minus negative x. Minus the negative becomes, I'm going to put plus x, that'll work. Is that the exact same as this original equation? No. So we're going to say it is not symmetric to the y-axis. Let's check origin. So I'm going to put in negative y and negative x. So if I'm checking origin, I'm putting in both with negative. Alright, negative y squared becomes y squared. And like Sparta already tried to say, minus the negative, we're just going to write as a plus. Is that the exact same again as the original? No. You do need to check all three. It is possible to be symmetric about the x, to be symmetric about the y, and to be symmetric around the origin. And you're thinking, what? What are you talking about, right? If I draw a line through the x-axis, is it symmetric top and bottom? And symmetric about the origin actually means if I draw in a slanted line, wouldn't both sides be equal? So this one works with all three. So you always have to check all three. Does that make sense? Now, you have a homework problem that looks like this tonight. So if you are confused, you need to either A, come see me during homeroom, B, come see me for 10 minutes after school and I'll try to explain it again, which is fine with me. Or if you are in VOTEC, C, email me so I know that I need to talk to you directly. You email me when you walk in, we talk quickly. Make sense? Because I know VOTEC students, there's no way you're coming to me in homeroom. Not possible. Okay, we're going to graph this one. The last problem is hard. This one's easy. I like this one. Hopefully you do too. What is my famous phrase that I use just with the parabola graph even? Switch the sign of what's inside, keep the sign of what's outside. So what's the vertex for this one? T0. Now, that's pretty simple so far, right? I'm not scaring Ryan away yet. So I have another question. What number is in front of this absolute value sign? A 1, right? That means your slope is 1. So I'm gonna plot a point at 2, 0. And then from there, I'm gonna go up 1 over 1, up 1 over 1, up 1 over 1. But I also have to do it the other way because it has to make the letter V. And that's it. That's an absolute value graph. Did I scare you yet? Okay. We're good. Okay, feeling good then. What if there was a negative in front? What if it was -1?
Just that one, right one. That one.
Good. Which would make it look like a happy V or a sad V. Sad V.
Can you put one on one behind?
Yep, for this one, because it's +1 is the source. Any other questions? Okay, so far so good. And our last page of notes. Write this down first, probably. Write this stuff down first, probably. Then write the key information from the problem and we'll do it. You will like these circles with me. Now, later in the year, I know you can say that again. Okay? But for this one, you will like it. No matter what level you're at, you will like circles. I promise I can make these easy. Now, the book actually assumes that you learn circles in geometry class, which is why this is in the first chapter. But I can tell you, Mr. D'Amico doesn't get the circles. So I'm going to teach this as though you've never seen it, but I'm going to make it easy. We're going to do two things with it. We're actually going to graph and do some other stuff. But the first thing, it does tell us, write the equation of a circle with the point 1, comma, -2, and the circle centered at -3, comma, -5. So I need two things to write the equation. And they're listed over here, center and radius. Which of those two things am I given in the problem? I'm given the center. Okay. So I know only the center so far. So I need to find the radius. How would I find the radius? What is a radius? From the center to any point on the outside of the circle, and it's a distance. So what lovely formula are you going to have to do with those 2 points? Go ahead and do your distance for me. Where you can find. All you're doing, Sparta, is finding the distance from the center to the end point. And that gives us the distance of the radius.
From center to end point.
Yep. Or you can call it from center to radius, if that helps. Alright, so you just found, hopefully, the distance from the center to a point on the circle, which is 1, comma, -2. What did you guys find? Did anybody find the answer yet? Mallory? 5? Anybody else agree? Whitney agrees? Okay. So I'm not going to show all the work there. I'm just going to say the radius is 5. Does that make sense? Well, I haven't got there yet. I'll show that in a second. All we've done so far is use the distance formula that you learned yesterday. So you just plugged those 2 points into the distance formula. Okay. So now, I'm going to write that equation. Now, notice it says both of these are in what? Parentheses. right? And normally what I tell you to do is switch the sign of what's inside, keep the sign of what's outside. There's nothing outside now. They're both inside. So what do you think I need to do with both of them? Switch both signs. So when I write this equation, I'm going to write x. Here's my lovely center. Instead of writing -3, I'm going to write +3. Minus the negative would make that. Switch the sign, it becomes. I'm not saying switch the sign and then use the formula. I'm saying switch the sign and plug it in that way. So if I switch the sign, I can plug it straight into the formula. So I'm using the opposite sign inside this. Make sense? So I'm going to put plus y plus 5. Again, I just switched the minus sign to a plus. I'm plugging in h and k. Remember, an equation always has what two letters in it? X and y. So I have to leave the letter x and y in it for it to be an equation. If I take those out, it's no longer an equation, it's just a number. Yes. Yes. Equals, what's 5 squared? And that's it. Make sense? Okay. What if I had given you two endpoints of a diameter? I'm just wondering, what would I have to do? I'd have to find the midpoint, good. And then from the midpoint, I'd have to find the distance from the midpoint to that point. You want to see how easy this is to graph? Go ahead, Whitney. It's r squared, so I have to square that 5. You ready to see how easy this is to graph? I'm not kidding. These are my favorite graphs. I find -3, 5. -5, sorry. -3, -5. I plot a point. Now my radius was 5, right? So I'm going to go up 5. Put a dot. Go back to the middle. Go over 5. Put a dot. Go back to the middle. Go down 5. Put a dot. Go back to the middle. Go left 5. Put a dot. And now I just connect them with the circle. You like that? I used the I found the center. I used the radius. I went up that many, over that many, down that many, over that many. I drew in 4 radiuses, more or less. I feel like Justin's thinking it's magic. Okay. Well, what I'm going to do right now is I'm going to give you the essential work. And if you have a question, please ask. But if you pull out a clean sheet of paper, here are your 6 problems for essential work tonight.